So this is going to be about solving absolute value inequalities and graphing the solution set. So if you understood how to solve a absolute value equation, this is not going to be that different. There is a couple wrinkles going on that you have to look out for, but the steps, the first couple steps are basically the same. You want to get all values that are outside of your inequality sign, absolute value sign, to the other side of the inequality. And then you are going to set up two separate inequalities. The first inequality will look exactly the same, minus the absolute value sign. And here's your first wrinkle here. The second inequality will be the same without the absolute value sign, and the other side must be multiplied by -1, and the inequality sign must be flipped. Okay, so you're still going to have two things that you have to solve, but both of these now are important. Multiply by -1 and flip the inequality sign. Here's a couple other things to keep in mind. If you're left with a greater than, the absolute value is greater than, and of course that also means greater than and equal to. Okay, you are working with an or compound inequality. An or compound inequality. If, the next step here, if you're left with a less than, absolute value is less than, then you're working with an and compound inequality. Okay, and so just make sure you keep in mind that the difference is or means that either solution is going to be fine, and means only shared solutions are going to be fine. And of course, just like this, you can also be equal to. Then you're going to solve the compound inequality, graph the solution set, and then you're going to pick a number, any number that's inside that solution set to test. So I'm going to start with talking about this one, and here's one that's going to, or at least should, send up some red flags for you, because you have to remember that anything inside an absolute value sign is going to end up being positive. So if you're asked, what is a value that will make this absolute value sign less than 0, that's absolute value less than 0, well, that's impossible, okay? And then just like in the equations, as long as there's no variable over here, and you have an absolute value being less than 0 or less than any negative number, then you have to say right off the bat that there is no solution, or the empty set. But remember, if there's a variable over here, you still have to go through the process. So I'm going to do this as one of the examples, and the first thing that we need to do is get rid of that 7 that's out front, since it's outside the inequality. I'm going to do that again by dividing. So then we're going to have the absolute value of 3x minus 7 being greater than or equal to 5. And now we're going to set up both of our inequalities. And keeping in mind that since this is greater than, absolute value greater than, this is going to be an or inequality. So our first one is going to be 3x minus 7 greater than or equal to 5, or 3x minus 7 less than and equal to -1 times 5. Remember, we have to multiply by -1 and flip this inequality. Now I'm just going to run through and solve these. So I'm going to add 7 to both sides and divide by 3. So 3x minus 7 is less than or equal to -5. Add 7 and divide by 3. So now I'm going to graph this so that we can see what we're exactly looking at here. So there's 2/3, and here's 4. X being greater than or equal to 4 looks like that. X being less than or equal to 2/3 looks like that. And so now, since it's an or statement, we're going to pick a number in each of these areas. Remember, these go on forever, and test them. And we had to see that they both work for it to see if both of these work or not. So you get to choose any number down here and any number up here. So I would suggest that you make it pretty simple and pick numbers that are easy to work with. So I'm going to pick 0 over here and 10 over here. And you can choose anything you want, but you should make your life a little bit easier. So we have to check these back into the original inequality just to be sure that everything is okay. And I'm going to use the manipulated one, where we simplified it just a little bit. And plug in 0, so 3 times 0 minus 7, is that greater than or equal to 5? So that's the absolute value of negative 7, and sure enough that is bigger, so we know that this one is a solution. Let's try the other situation. I'm going to use 10, so absolute value of 3 times 10 minus 7. And is that, is that greater than or equal to 5 as well? So that's 30 minus 7. And so then the absolute value of 23 is greater than or equal to 5. So we're happy. We know both of these work, and that compound inequality works. So for the final example, we're going to look at this inequality, this absolute value inequality. And again, we have to deal with the 2 and the 5. We need to move those over before we even set up our inequalities. So I'm going to subtract the 5 and divide by 2. And since we have an absolute value being less than a number, this is going to be an AND statement. And so we're going to set it up the same way. Just realize that an AND statement will change the way we have to test our solutions. So we're going to go 1 plus 2z is less than or equal to 2, and 1 plus 2z, we have to flip the inequality and multiply by negative 1. So on this left one first, I'm going to subtract 1 to the other side and divide by 2. Multiply by negative 1 here. So 2z is greater than or equal to negative 3, and z is greater than or equal to negative 3 over 2. So let's throw this on the graph, take a look at it. All right, we got negative 3 halves here. We got 1 half here. Remember, this is an AND statement. So we have z being less than 1 half, and also z being greater than and equal to negative 3 halves. And since this is an AND statement, both of these statements individually go on forever and ever, but since it's an AND statement, it's just the part that they share. And a lot of times you see it like this, where they're just in between the two. And so this is pretty nice because we only need to pick one number that's in this range here and to test it. So again, I'm going to go back to the original to test it, but a little bit manipulated. And so that's going to look, move this up. Oh, so, by the way, I'm going to pick 0 because that's a super easy number to work with. So I'm going to do the absolute value of 1 plus 2z being less than or equal to 2, and I'm going to plug in 0. So we have absolute value of 1 plus 2 times 0 being less than or equal to 2, which is the absolute value of 1 being less than or equal to 2, which of course is true, and so we know all the numbers in between those two are our solutions.